All right, let's dive into a topic that honestly sounds like it's straight out of science fiction, but is becoming a very real, very strategic problem: the collision course between quantum computers and, well, the entire foundation of our digital security. I mean, this quote from Boston Consulting Group just hits the nail on the head, doesn't it? We are talking about a potential master key for the entire internet, a single key that could unlock basically everything, from your bank account all the way up to national secrets. The real question is who's going to build it and when?
So here's how we're going to break this down. First, we need to understand the problem itself, what we're calling the quantum key. Then, we'll look at the pretty ingenious solution that cryptographers have come up with, a new kind of lock. But we're also going to see why the danger is already here, right now, in a section we've called The Harvest Has Begun. That, of course, leads us to the race against time. And finally, we'll look at why just having a solution isn't nearly enough by digging into the strategy gap.
Okay, so let's start at the beginning. The problem. How in the world does a quantum computer become this kind of master key, one that's capable of breaking, well, basically everything? Pretty much everything we do online, every email we send, every transaction we make, is protected by a system called public key cryptography. And it's a really simple, brilliant idea. There's a public key that anyone can use to lock up data, but only you have the one-of-a-kind private key that can unlock it. This is the bedrock of our digital world. Now, the whole reason this system is secure is because it's based on math problems, like factoring enormous numbers that are just practically impossible for our current computers to solve. But, and this is the kicker, quantum computers don't play by the same rules. They are built from the ground up to solve exactly these kinds of problems, which means our current digital locks could become totally useless. And listen, this isn't some far-off hypothetical thing. The expert consensus is pretty clear. There is a greater than 50% chance that a quantum computer powerful enough to break our most common encryption standards will exist by 2035. That's not a suggestion, that's a deadline, and it is coming up fast. And you have to understand, the threat isn't like a single light switch that gets flipped on one day. It's more like an escalating wave. It's projected to start right around 2035, with governments and spies targeting national secrets. But by 2040, that same power could be in the hands of organized crime, then corporate spies, and eventually maybe even terrorists targeting our critical infrastructure. Okay, so that's the scary part. The master key is coming. But thankfully, the world's best locksmiths, the cryptographers, are already hard at work building a whole new kind of lock. The solution is called post-quantum cryptography, or PQC for short. And this isn't just, a slightly stronger password. It is a completely new generation of algorithms. They're built on totally different math, things that are believed to be incredibly hard for both our regular computers and for quantum computers to crack. And this solution isn't just a theory anymore. It's here. After this huge multi-year global competition, the U.S. National Institute of Standards and Technology, that's NIST, they finalized the very first set of PQC standards back in 2022. So these new algorithms, with their cool names like Crystal's Kyber, are ready to go. The technical fix actually exists. But, and this is a huge but, having a new lock and actually installing it are two very, very different things. There is a massive adoption gap. So yeah, about half of the world's top 10 websites are already on the move, implementing PQC. But that number just plummets when you look at the wider internet. For the top 1 million sites, adoption is a shockingly low 9%. And this brings us to a really crucial point. Why is that 9% so incredibly dangerous? Well, because the threat isn't just something off in the future. In a very real sense, the harvest has already begun. This is what's known as the harvest now, decrypt later strategy. Right now, as we speak, adversaries are stealing and storing enormous amounts of encrypted data. They can't read it yet, of course, but they're stockpiling it. They're just waiting for the day that a quantum computer finally gives them the key. So any data that has long-term value, think government secrets, corporate R&D, your health records, it's already at risk. This is exactly why waiting is just not an option. I mean, history shows us that these huge global cryptographic transitions take a decade or more. The switch to AES encryption took 16 years. So if the quantum threat really hits by 2035, and it takes us that long to migrate, well, you can do the math. We're already behind.
So this isn't just a technical race against the clock. It's an economic one too. The cost of doing nothing is measured in billions of dollars and, frankly, some devastating risks to society. There's a really clear financial reason to act now. Boston Consulting Group figures a big company that starts its PQC transition early might spend about $25 million. But if they wait until the deadline, that cost could easily double. And that's not even counting the astronomical price tag of an actual data breach. And the risks here go so far beyond corporate balance sheets. The stakes for all of us, for society, are incredibly high. We are talking about the potential for car sabotage, massive financial fraud, government espionage, and ransomware attacks on life-saving equipment in hospitals. This is really about protecting the fundamental systems that we all depend on every single day.
So we have the problem, and we even have the solution. So what's stopping us? This brings us to our final section, what's being called the strategy gap. What you're looking at here is really a tale of two different plans. On the left, you've got a super clear, detailed roadmap for businesses to achieve what's called crypto agility. It's a playbook. But on the right, you see the high-level goals of the U.S. national strategy. And according to a recent government report, while the goals are good, the plan itself is missing the specific milestones and performance measures you'd need to actually make it happen. Yeah, that report from the Government Accountability Office found some major gaps in the U.S. national strategy. There's no single person or group in charge of coordinating everything. There's no clear plan for how to get the private sector to switch over. There aren't even any metrics to track progress. So this isn't a technical problem anymore. It's a leadership and a coordination challenge. And that leaves us with this really powerful final thought. The move to a post-quantum world isn't just some technical upgrade. It's a fundamental strategic choice. The question for every leader, whether you're in government or in business, is actually pretty simple. Are you going to be part of building the trusted foundation of the next digital economy, or are you going to be one of the ones left trying to explain why you waited?